Hey, what's up? Mr. Myasis here. What I want to do today on this video is I would like, first of all, how you doing out there? Tough times we're having. Hopefully you're doing good. Hopefully you're doing fine. I don't know if I'm going to bring any joy whatsoever to your spirit or your heart. But you know what? All I have to give you is statistics and GeoGebra today. So hopefully that helps you in some small way. But here we go. So what I'd like to do today is talk to you about one proportion inference on GeoGebra. So what is one proportion inference? Well, that's just when we look at, we're looking at one proportion, one sample, and we're looking at either confidence intervals or a hypothesis test. So I'm going to show you to do both of them on GeoGebra. I know I have another video on how to do a confidence interval in GeoGebra. I just want to kind of put it together. So hopefully this will help you out. So here we go. So I've got this problem here. In 2020, if you're watching this and it's not 2020, then you can kind of reminisce about this. But if you are watching this and it is 2020 right now, you know that a very popular game is called Among Us. And so let's suppose that, Among Us is played on a lot of different platforms. You can do it mobile, online. It's just on PC. On one of those platforms is called Steam. And suppose we take a random sample of 250 college students at CSU Stan. Stanislaus is where I teach. I teach at CSU, Cal State University, Stanislaus. And suppose they play the game. So all these, this random sample are already students that play this game already. And we ask them if they use Steam to play Among Us. Now, of those surveyed, 15% replied that they do, in fact, use Steam. Although we might question that if they see if it's really a fact or not, because they might be an imposter. Anyway, estimate the true proportion of CSU Stan game players that use Steam as their platform to play Among Us. And to do this estimate, we're going to create and interpret a 90% confidence interval. So a couple things we have to do first is we have to figure out what n is. So my pen is not working today. So I'm going to do a lot of this typing. So n is going to be equal to the sample size, which in this case is 250, right? P is going to be it's actually p hat. So we're going to go p. You know what I'm going to do for this? Because my pen is not working, but I'm still going to try to draw this. I'm going to try to draw a hat here. Okay, p hat equals. All right, let me go back to my typing. I don't want to draw anymore. So type. P hat is going to be equal to 0.15. Oh, look at that! Just kind of messed up my. You know what I'll do? I got an idea. Let's do this. Let's insert an equation. So let me insert this equation, and then I'll come. Okay, so I have p hat here is 0.15. I put that equation in, and then I need to have the number of successes. So number of successes, give myself some space. Number of successes is going to be equal to 0.15 times 250, because I don't actually have the number. All I have is the percentage that they gave me. So let me calculate that. So we're going to go ahead and calculate that out. Oh, look at that. It already did it for me. 37.5. I can't really put 37.5 in GeoGebra, so I'm going to go ahead and put 38 I'm just going to round up. Okay, so we're going to go to GeoGebra and create our confidence interval. So let's go and do that now. So GeoGebra, we're going to go to Classic. We're going to go to Probability, Statistics, and we want the Z estimate of a proportion. Okay, that's what we're dealing with, proportion. All right, perfect. I believe we said a 90% confidence interval, so I'm going to change the confidence level to 90%. My successes, we said, was 38 out of 250. It should be around 15%. There we go. 0.15, we can always check there because our interval is going to tell me what it is. So I'm just going to cut and paste this really quickly into my document. All right, folks, so now that I have this cut and pasted into my document, what I'm going to do is really look at creating my confidence interval. So here's my interval. This right here, this is my margin of error, right? That's my margin of error, so I know we're going to be a plus or minus 3.73%. But really what I need here is my lower limit and my upper limit. Right? That's going to tell me what my confidence interval is. So what I'm going to do is write out my interpretation of my confidence interval. So I'm going to say, we are 90% confident. You always start it off like this, confident, that the true proportion, right, the true proportion of all CSU Stanislaus students, remember we're talking about all of the students, not just the ones in our sample. So we're 90% confident that the proportion of all CSU STAN students that play among us on Steam or using Steam is between 11.47% and 18.93%. Okay? All right. So then we are going to go on. That's it. That's all this is all we have to do. This is all we need to do use GeoGebra to find our answer. That's the goal. All right. Now we missed the conditions for inference, but I'll show that to you in the hypothesis test. All right. So here, let's take a look at our hypothesis test. So let's say we have the next question. According to Among Us user data, about 12% of Among Us players access the game using Steam. Is there evidence that the proportion of CSU STAN players that use Steam is significantly greater than what we see in the population or of all people? So at first glance, I just want to show you, at first glance, 12% is in our interval. So based on our confidence interval, we actually can see that 12% could be the true proportion of what we see at STAN State also. Remember that this was in our sample. This is our estimate of the true population of STAN State students. Since 12 is matched up, you know, it's likely that there really isn't any evidence that it is significantly greater because it could possibly be 12. But let's take a look at how the hypothesis test would look like for that. All right, so there are 4 steps to the hypothesis test, right? There's the hypothesis, and there's the conditions for inference, there's the mechanics, which we're going to do in GeoGebra, and the conclusion. So let's take a look at each of those 4 pieces, and I'll try to make this as quick as possible because I know I'm already at 7 minutes for this video. So the hypothesis. So here's the hypothesis. Because this video is really about looking at GeoGebra, I'm just going to kind of fast forward through these things. But here's the hypothesis. P is equal to 0.12 and P is greater than 0.12. Remember, those have got to be the same number. Greater than because we're looking at whether or not it's significantly greater, right? It's in our problem. P is going to be the proportion of all CSU STAN Among Us players that use Steam, because we're using our sample to see if it matches up with the true proportion, or what we think the true proportion should be. Our conditions: random sample. We assume that 250 is less than 10%, and we do our NP and NQ to make sure that they're greater than or equal to 12 to see that our sample size is big enough. So we're going to be able to. So we're going to use. We're going to use a 1 prop z-test. All right, so this is what we're going to do. We're going to use a 1 prop z-test. We're going to do that in GeoGebra. So let's go to GeoGebra. We go to statistics. We're still in statistics. You're going to go to z-test. We were at estimate, right? This was our sample size. This was our confidence interval. Now we're going to go to z-test of a proportion. Our null hypothesis is 0.12, 12. Our alternative is greater than. We can choose any of these that we want. Okay, we're going to go greater than. Our successes were 38. Okay, it remembers this from before. And 250. And here's our results. All right, so I'm going to go ahead and cut and paste that into my document so that I can have it there. So we're going to cut and paste this guy in here, and we've got all our stuff that we need. We have our z-score, which is 1.557, and we've got our p-value, which is 0.0597. Now, one thing I want you to recognize here is that our alpha level is going to be 0.05. Now, normally, we normally say, well, it wasn't given to us, but we did have a confidence interval, And since the confidence interval was 90% confidence, we take the confidence level, subtract 1, so we get 10%, and we look at whether this is a greater than, less than, or a not equal to. If it's a greater than or a less than, then that's called a one-tail test. One tail meaning we're going to take the difference that we got here, which was 10%, and we're going to divide it by 2 because we only have one tail, and we're going to get 0.05 for our alpha level. If the alternative hypothesis had a not equal to symbol, then that would be a two-tailed test, because a not equal to means it could be greater than or less than, right? We're looking at two sides. So in a two-tailed test, we would take the difference here, which would be 10%, and that would be our alpha level. We would not have to divide by 2. We would have an alpha level of 0.1. So we can determine the alpha level based on our confidence interval from before our confidence level. So given our alpha level is 0.05, we're going to come out with our conclusion here. And our conclusion is based off of our p-value. So we're going to say since our p-value of 0.0597 is greater than our alpha level, we will fail to reject, right? A p-value that's bigger than our alpha level, we're going to fail to reject the null hypothesis. So what does this mean in context? This means that there is not enough evidence that the proportion of, you know what I'm going to do? I'm just going to copy and paste this. You know, because that's really what we're talking about. Okay, that the proportion of CSU stand players that use Steam is significantly greater than, that's what we're trying to show, right? We're trying to show that it was greater. But since we rejected the null, or since we failed to reject the null, then that means we didn't have enough evidence to prove that, to show what we wanted to show. So we're going to write that out. There is not enough evidence that the proportion of CSU stand players that use Steam is significantly greater than the population, which was 12%. All right? So this would be our conclusion. Bam. That's it. That is all there is to it. So there's there's an entire hypothesis here and a confidence interval using GeoGebra. We'll catch you next time, guys. Again, remember, don't forget to subscribe for more stats videos and more other math videos. You want some other math? Let me know. We'll catch you later. See you guys.